So we're going to do a quick, this is the last week of class. Well, we have Monday next week. So Thanksgiving break starts Wednesday, and then you come back. We have 2 Mondays left, but the last Monday is going to be reviewed. And then finals start December, I want to say 2nd, if that's a Tuesday, then it's December 2nd. So not a lot of time left, semester's flown by. And this is a busy week for the school. They're going through their accreditation process this week. So when you see people in suits walking around and people's faces really scared, that's probably why. So we're just going to do a quick review of start chapter 13 again, finish it off today. Then we're going to start 15 if we get to that today, if not Wednesday. So what this is showing us is a pathway of how your body communicates from receiving a signal to making an action happen. It's very, very similar to what we talked about in homeostasis in the feedback cycle. So there's going to be some type of stimulus. What detects a stimulus? The receptors. Okay. Got to start clickers. Okay. Now, once the receptors detect that stimulus, how does information get into the brain or the spinal cord?
No, into
sensory neurons. So this blue neuron is a sensory neuron. It has to take the information into the brain or spinal cord. The sensory receptors are going to be outside of the brain and spinal cord, so are they in the peripheral or the central? Okay. The peripheral nervous system. So sensory neurons are traveling from the peripheral into the central nervous system. Now, once they get into the central nervous system, what has to happen with that information that they brought in? They have to do what? Analyze it, interpret it, evaluate it, whatever you want to call it. What type of neuron can do this interpretation? The interneuron. Now, in general, the interneuron will be present, but it does not have to be. So if we look at this picture right here, you can see this little purple neuron. That's your interneuron in this picture. But it doesn't have to be present. Usually it is, but it doesn't have to be. Now once we analyze that information, notice where is it being analyzed. Is this going to be gray matter or white matter? Gray matter. Which means, is there myelin or no myelin?
No myelin.
No myelin. So interneurons are always unmyelinated, so they're going to be in the gray matter. It's going to analyze this information, and then we need to actually do something with what the information has told the body. So what's going to happen next? What type of neuron does output go down? So in this picture, both the green and the reds are different types of motor neurons. The information is going to be sent out, so it's going from the central nervous system to the peripheral. The motor neurons carry information to what?
The muscles or glands.
Muscles or glands. What do we call muscles or glands? What's their component name? Well, efferent's the output. That's the same as motor output. It sounds similar to efferent. Effectors. So these guys are your effectors. So basically, a motor neuron takes information to the effectors, and it tells the effectors to do something. Contract, secrete, relax, it depends on the situation. So, you have 5 components. What's the first component? Then what? Sensory neuron. Then interneuron, which is integration. Then motor neuron, and last? That's the same as your feedback cycle component. So this is the same information we learned in chapter 1. It's just carrying through the later chapters. Receptors first get to detect before they can send information. So in this picture, we said this last week, it's going to be in the upper dermis. It detects light touch or vibrational touch. Starts with an M. Merkels are in the epidermis. Meissner. So this one's showing Meissner corpuscle. That's the sensory receptor here. Okay, now I want you to look at this picture. This is the gray matter. Here's the motor neuron exiting the gray matter. How many motor neurons do we see exiting the gray matter from here to there? So here's the cell body, here's the axon, there are the end bulbs, so how many? One. This is skeletal muscle. Now look at the green pathway. Here's the cell body, here's the axon exiting, here's another cell body, there's the axons exiting. How many are in this pathway?
3.
So here's the first one, follow it down, there's the second one. So there's 2. They're just showing you branches of the axon because there's 3 possible effectors. So, do we control skeletal muscle?
Yes.
Okay, so is this somatic or autonomic?
Somatic.
Okay, so how many motor neurons are in the somatic pathway?
1.
1. Okay, what is this? This is your heart, smooth, and glands. Do we control those?
No, it's not.
That's autonomic. How many motor neurons are in that pathway? 2. Big difference when we're talking about functionality, and that's what's going to lead us into chapter 15.
Is it always 2 or is it just?
It's always 2, except for there is one exception, and we'll get to that in chapter 15. So whenever we go to skeletal muscles, only one motor neuron goes to that skeletal muscle. Now, you can have multiple motor neurons go into it at once, but from your gray matter in the spinal cord to that skeletal muscle, one motor neuron. So if it's leaving your lumbar region and going to the toes, that's one long motor neuron. If it leaves your cervical region and goes to maybe your trap muscles, that's not as long. So it's just as long as the traveling distance. But if we look here, to your heart, any type of smooth muscle or glands, there's going to be 2 motor neurons. So the pathway is a little bit different. Okay. So this is just basically what we were discussing right here. Now, what I want you to notice is this is the back of the spinal cord. Here's the front of the spinal cord. Is sensory information going into the back or the front? Yeah, so if you follow here, here's your sensory neurons. They're entering the back of the spinal cord. So where's motor information exiting?
The front.
The front. All sensory information goes in the back of your spinal cord. All motor information comes out the front. So if we damaged this area right here, what would this segment of the spinal cord not be able to receive? Yeah, sensory information. If we damage this segment right here, what would this area not be able to send out? Motor information. Sensory always enters the back, motor always exits the front. Now, I also want you to look here. This area right here that's in the back of the spinal cord, it only has blue axons. So this area in the back is only what? Sensory or motor?
Sensory.
Notice here in the front, both the red and green are motor neurons. So this front area only has what?
Motor.
But notice that they come together right here. When they come together, do we have both sensory and motor?
Yes.
Okay. So this area that's about to exit that they cut off right here, this is a spinal nerve. All spinal nerves are mixed. What does the word mixed mean? What does it contain both of? Sensory and motor. So all spinal nerves are mixed. Anytime you use the word all in biology, it's kind of scary because usually there's always an exception. But in this case, it's true. All spinal nerves are mixed. And that means they carry both what? Sensory and motor. Okay. Now, there's a difference though. So here's a spinal nerve, they're mixed. We also have cranial nerves in your body. Cranial nerves are going to come off what part of your body? The brain. Cranial nerves can be only sensory, only motor, or they can be mixed. So can I say all cranial nerves are mixed?
No.
No, some will be, but not all. So all spinal nerves are mixed, meaning they contain both sensory and motor axons. But are all cranial nerves mixed? No. There's a mixture of sensory, just motor, and then there is some mix. Okay, So sensory information comes in the back, motor exits the front. So kind of keep that in mind when we talk about pathways and reflexes. Okay. So this is just showing you a spinal cord with all of its sensory structure, or sorry, not sensory, all of its nerve structures. Here's your spinal cord. You'll see the gray matter in the middle, the white matter on the outside. Okay, this is the back of the spinal cord. So what is this information coming in right here? Here's the front, once it's exiting right here. But you see how they come together right here? So what is that? Spinal nerve. Is it sensory, motor, or mixed?
It's mixed.
Mixed. Okay, so this is just so y'all can get a picture of how information travels. Travels in sensory, out motor, and then it comes together at the spinal cord. So it keeps it separate. It's like a highway. We got two sides. One goes one way, the other goes the other way, but sometimes they come together on one road. So that's kind of how your nerves travel. Okay. So what we're going to concentrate on are reflexes. I got to get to them, so let me just go exit out of this. So a reflex is basically a quick movement. All reflexes are some type of protective mechanism. So everything in your body is geared towards homeostasis. We want to maintain what's normal. So if you step on something sharp, what are you going to do? Yeah, pick your foot up. You're trying to get away from something dangerous. If you sense something a little frightening, a lot of times you'll actually just get away from the situation. If someone's chasing you with a knife, you're going to run. So your body is going to react to protect yourself. Okay? This is called a reflex, basically reacting very quickly to protect yourself from some type of danger. Reflexes can be voluntary or involuntary. If they are voluntary, what system controls it? Somatic. If it's involuntary, what system is going to control it? So your reflexes can be considered somatic or autonomic. Somatic reflex means it's going to be skeletal muscles voluntary. Autonomic means what type of effectors? Heart, smooth, and glands. Now the other thing about reflexes is the integration center. Where does integration occur? So if we look at this picture, we're seeing the spinal cord. So if the integration, basically analyzing what's going on in your body, is occurring in your spinal cord, we call it a spinal reflex. Basically anything that's occurring with your limbs are going to be a spinal reflex. So arms, legs. Because if you think about your limbs, they're closer to your spinal cord. Okay, but what about something happening in your face region or your neck region? What is that closer to? Your brain usually. So another type is going to be a cranial reflex, and this means the integration center is your brain. And this is going to be more focused on basically your facial reflexes, heart, lungs, stuff like that. So if I said you had a spinal somatic reflex, the spinal tells you what about that reflex? It's going to basically be controlling the limbs, and where's the integration center? The spinal cord, okay? But by me saying somatic, what do we know the effectors are? Skeletal muscle. Okay. So somatic and autonomic are just telling us what the effectors are, so which system controls it. Spinal and cranial tell you where the integration center is. Is it the brain or is it the spinal cord? You have tons of different types of reflexes. You have spinal autonomic, spinal somatic. You have cranial autonomic. You have cranial somatic. So you have different types. But what I want you to notice, what?
That was spinal somatic.
No, you can have a whole combination of them. So if I said spinal somatic, that means the integration center is in the spinal cord, and then that the effectors will always be skeletal muscles. So I can make a combination of all of this. I could have spinal autonomic, spinal somatic. I can have cranial autonomic, somatic cranial. So it's just a combination. So one's telling you where it's integrated, the other tells you what the effectors are. So you can have any type of combination. But the whole point of a reflex is protection. So that means information has to go in, you gotta analyze it, and information has to go out. Same thing as how information travels into and out of your spinal cord, same thing as a feedback cycle. So here's a pin. What's gonna detect this pin poking the skin? Okay, sensory receptors. Then, how does that information get to your brain or spinal cord? Sensory neuron. Once the sensory neuron takes that information in, what happens to it? It's analyzed. What usually analyzes this information? Okay, so this is where integration occurs. Once we integrate, we need to send information away. So what's that? Okay, and then that motor neuron is going to take information to the effector. Okay, this effector happens to be skeletal muscle. So is this somatic or autonomic? And integration is occurring in the spinal cord, so is it spinal or cranial? Is this the same pathway we just talked about in the other picture? Okay. These pathways don't change. We have to have these components to occur. This is known as your reflex pathway. It's really the same thing as feedback cycle. It's the same thing as information comes in and information comes out. So we just put new names with the same processes. Nothing changes. Okay. How many components are in the reflex pathway? 5. If this was your brain and not your spinal cord, what type of reflex would it be? If this was cardiac muscle and not skeletal, what type of reflex would it be? Autonomic. Yeah. So it's just about looking at a picture or reading the scenario and figuring out what it's talking about. Okay. Now, there are 4 major spinal somatic reflexes. 4 major spinal somatic. This is what we're concentrating on because we're in the spinal cord chapter. So if we were in the brain chapter, we would concentrate on cranial reflexes. Now, spinal somatic. What does the spinal tell you? The integration occurs in the spinal cord. Somatic tells you what are the effectors? The skeletal muscle. So the 4 that we're going to talk about are spinal somatic. Integration in the spinal cord. Skeletal muscles are the effector. And there's 4 types. Most of them are very similar to each other, just a little bit different outcome. We have the stretch reflex, the tendon reflex, the flexor reflex, also known as withdrawal, whichever name you like, fine. And we have the cross extensor reflex. So these are the 4 spinal somatic reflexes. They're all going to involve limbs. And their main function is to protect you. Basically, get you out of harm's way. So y'all told me if you stepped on something sharp, what would you do? Pick your foot up. If you put your hand on a hot stove, what would you do? Take your hand off. All of these are reflexes. Even though you know it's happening, it's actually occurring without you thinking about it. You know it happens basically after the fact. So it's happening very quickly to protect your body, to protect the limb. Okay. In all of these reflexes, we have 5 components. What are those 5 components? What detects the stimulus? How does that information get to the brain or spinal cord? Once it's in the brain or spinal cord, what are we going to do? Analyze, integrate, I don't care what word you use. Once we're out, what's going to happen? We have to get information out. And that motor neuron takes it to the... Okay. Now, for any reflex, there's a few terms that you have to understand that describes the reflex. The first term is going to describe what side of the body it's on. So we have two things that can happen. Everything can occur on one side of the body, or things can occur on opposite sides. If stuff occurs on one side of the body, it is known as ipsilateral. This means that the sensory information goes in one side, the motor information exits the same side. So look at this picture. You see the blue, that's your sensory. It goes in, and the red's your motor. Are the blue and the red coming out the same side of the spinal cord? Yes. So this would be an ipsilateral reflex. Anytime the sensory goes in the same side the motor exits, it's considered ipsilateral. It's only happening to one side of your body. So I'm waving right now. Granted, it's not a reflex, but am I really just using one side of my body? Okay, so this would be ipsilateral. But really almost everything that you do requires both sides of your body. Walking, am I using both sides of my body? Yeah. Okay, if you step on something sharp, so I'm stepping down with my right leg, I'm on something sharp, what do I need to do with my right leg? Okay, so if I'm like this, if I pick my right leg up, I'm going to fall on my face. So what do I need to do with my left leg?
Push it back.
Push it down and pick this one up. Is that involving both sides of my body? Yeah. Okay, that is known as a contralateral reflex. So ipsilateral is same side, contralateral is opposite sides. Let me show you a picture of contralateral. Okay, it kind of looks busy, but do y'all see how the sensory neuron goes in on your right side? So this is my right side. Do you see all these reds? See how they're coming out the opposite side? So if the sensory goes in one side, motor comes out the opposite, it's what? Contralateral. Okay, if sensory comes in one side, motor goes out that same side, what is it considered? Ipsilateral. Okay. Now, that's one term that you need to understand. The other term that you need to understand is what's going on inside the integration center. Okay, this is going to explain how many communication points do we have. How many communication points are inside the integration center. What do we call communication between two neurons? Synapse. What do you call between a neuron and a muscle? Okay, so this right here is the neuron in the muscle, that's an NMJ. But up here, do you see where this blue meets the purple? That's a synapse. So same communication is occurring, but one's between a neuron and a neuron, the other's between a neuron and a muscle. So when we talk about what's going on inside the integration center, we're talking about how many neurons are synapsing together. There's two possibilities. You can have monosynaptic, or you can have polysynaptic. What does mono tell you? Okay, so if you look at this picture, here is your sensory neuron. It's coming down here, and it's synapsing with your motor neuron, and it's exiting. So this is one synapse. So we would call this mono. Now here is a sensory neuron coming in. It synapses with your interneuron. The interneuron synapses with the motor neuron. How many synapses is that? So it has to be more than one, which is polysynaptic. Most reflexes in your body are polysynaptic. There's only one that we're going to learn that's mono.
That's when it goes from sensory neuron to motor neuron.
If it's mono, it has to skip an interneuron. So if it's monosynaptic, the interneuron isn't present. So you remember I said interneurons aren't always present? They usually are, but they aren't always. That's going to be a little faster though if there's no interneuron present because we're taking out the middleman. It's one less communication point, which means the process is faster. Okay, the last term we're going to go over right now is I want you to look at this picture. These red ones are motor neurons. This motor neuron is a solid color, which means it's an excitatory effect, which means it's sending a signal. If it's sending a signal, does that mean depolarization or hyper?
Depolarization.
Okay, so that little plus means it's excitatory, and this neuron, this solid color neuron, is going to be depolarized. Okay, that neuron's going to excite this muscle, which means that muscle contracts. Now, what do you notice about this neuron? It's not solid, it's dotted. What does it have beside it? So is that D or hyper?
Hyper.
If it's hyperpolarized, that means it's not getting close to threshold. So is it going to send a signal?
No.
So this motor neuron that's sending a signal to the opposite muscle is basically not exciting that muscle, so the muscle is relaxing. Okay, when neurons work together to do opposite effects on muscles, we call this reciprocal innervation. Reciprocal innervation is when motor neurons have an opposite effect on muscles. So in this picture, the quadricep muscle is being excited, so the hamstrings are being relaxed. So quadriceps contract, hamstrings relax. If we relax the quadriceps, what's going to happen to the hamstrings? They're going to get excited and contract. So it's just opposites. If I'm contracting my biceps, what's this muscle right here? It's that opposite triceps, opposite of biceps. So I'm contracting biceps, so triceps is relaxing. If I contract triceps, what's happening to my biceps? It's relaxing. They're opposite muscles. It's called antagonist groups. So they do opposite effects. Every muscle in your body has at least one muscle that does something different, the opposite.
So reciprocal innervation
Is when motor neurons do opposite effects on muscles. So right here, this muscle right here is called the palmaris longus. It allows me to do this, which is closing my angle. What's closing the angle?
That's extension. No, flexion.
Flexion, okay? So as my palmaris longus is flexing, which is contraction, I have a muscle on the opposite side called the extensor digitorum that's going to be relaxing. But if my extensor digitorum contracts, which is this, what's happening to my palmaris longus? It's relaxing. It's just opposite muscles. Again, most muscles have more than one opposite guy that does the work, but in general, we just know that there's something that contracts, another one has to relax. And that's reciprocal innervation. Okay, so let's start off talking about the stretch muscle, or the stretch reflex. The stretch reflex is going to occur when muscle spindles, or let me just say, when the receptors detect increased stretching. The stretch reflex occurs when the receptors detect increased stretching. If your muscle is being stretched beyond what's considered safe, that's going to be considered dangerous to your body. So your body is going to do something to protect itself. So if you're stretching your muscle too much, your body's going to make that muscle contract. And it's just protection. If one muscle contracts, what is the muscle's opposite one have to do? Relax. Okay. So, all I said was that the stretch reflex is a reflex that reacts to excessive stretching. So there has to be a receptor that detects that. Do y'all see this little thing that kind of looks like lips Okay, this is called a muscle spindle. It's just a type of receptor. Muscle spindles detect excessive stretch. Muscle spindles just detect excessive stretching. So all muscles have them. When this muscle spindle detects lots of stretching, that's the receptor. How's that information going to get to your spinal cord? Before the integration. Sensory neuron. So we have our first component, which is the sensory receptor, which is muscle spindle. Okay. How does this information get to your spinal cord?
Sensory neuron.
Sensory neuron. Okay, that sensory neuron gets excited, so it's sending a signal. Now, that signal gets to the spinal cord. It's in the gray matter now. What has to happen next? Integration. Okay. Now, in this particular case, in the stretch reflex, we have two pathways. You see we have two motor neurons? We are looking at the main pathway. The main pathway is this one right here. Follow the sensory neuron in. It connects with this motor neuron. How many synapses do we have?
One.
A stretch reflex is monosynaptic. The main pathway is monosynaptic. So a stretch reflex protects your muscles from excessive stretching. The main pathway is monosynaptic. So it's exciting this motor neuron. So we have our integration occurring. It excites the motor neuron. The motor neuron is going to go to the muscle that's stretching too much. And what is it going to tell that muscle to do? Not relax, but contract. So notice this muscle is stretching. That's your quad muscle. We want to tell that quad muscle to contract, basically opposite of overstretching. Now, if this muscle is contracting, what needs to happen to this muscle, the hamstrings? Okay, so notice at the same time that the main pathway is telling this muscle to contract, what is happening as a secondary pathway? It's telling it to relax. Since these are opposite muscles occurring, one's contracting, one's relaxing, what do we call that term? Reciprocal innervation. Okay. Now look at this. Is this picture one of ipsilateral or contralateral communication? Ipsilateral. It's occurring on the same side. Okay. So we have our 5 components. Muscle spindle sends information in by the sensory neuron. Once we get into this area, what is that area? The integration center. Okay. The integration center is going to tell us what to do, so we're going to send output. How do we send output? Motor neurons. Okay, and those motor neurons are going to synapse with what? The effectors, which in this case are muscles, skeletal muscles. So is it somatic or autonomic? Okay. The main thing I want you to get out is know the different reflexes, but the pathways, they don't change. The components might change, meaning that we don't call them all just a receptor, but those 5 components are always present. So if I gave you a picture, you should be able to just tell me a story based off of that picture. The components are always the same. Okay. So the stretch reflex, monosynaptic, ipsilateral, protects muscles from overstretching. Okay. Does this picture look a little similar? Okay, but let me go back and just show you this one. Okay, notice that these sensory receptors in the muscle. Do y'all see the blue here? The sensory receptor is not in the muscle anymore. What is that connects muscles to bones? It's in the tendon. This is called the tendon reflex. The tendon reflex is basically the opposite of the stretch. The stretch reflexes causes contraction. Tendon reflex is going to cause relaxation. So the tendon reflex protects your muscles from getting overcontracted. And it causes relaxation. I want you to look in this picture. is everything entering and exiting the same side. So what would we call it? So the tendon reflex is ipsilateral. Look on the inside, regardless of which pathway you look at. Here's sensory, intermotor. How many synapses?
2.
So is it poly or mono? So the tendon reflex is polysynaptic. So it doesn't matter which pathway you want to look at, you can't get it wrong. They're both polysynaptic. Okay. So in the tendon reflex, basically you're going to have sensory receptors in the tendon that detect excessive contraction. These are called Golgi tendons. So in the tendon reflex, you're going to have receptors that detect excessive contraction, and they're called Golgi tendons. So they're basically detecting lots of pulling.
What do they do?
Detect excessive contraction. So basically they're detecting lots of tension. Once they detect that, what are they going to do? What's the next step in the pathway? Sensory neuron. So sensory receptors, Golgi tendons, detect excessive contraction. Then they're going to send information through what? Sensory neuron. The sensory neuron goes into the spinal cord, and what happens there? We got integration. Now notice we have integration with 2 neurons, 2 motor neurons. One motor neuron is a negative. So is this excitatory or inhibitory? The other one is a positive. So what's that one? The inhibitory one is going to the muscle that's already contracting too much. So if it's getting inhibited, is it going to keep contracting?
No.
It's going to relax. What is the excitatory one going to then? It's going to cause contraction. Notice they're opposite muscles. The relaxing one is the quads. The contracting one is your hamstring. It could be the same with your arm, but this is just showing you in your leg. Okay? So once we integrate, we have to send information down the motor. Okay? And then the motor neuron is going to take information to your effectors. The pathway doesn't change.
I have a question.
Okay.
So it goes from the Golgi tendon to the sensory receptors?
No, the Golgi tendon is the receptor.
Okay.
Yeah. So there are probably about 60 different receptors in your body with specific names. So we've always just called them sensory receptors, but now we're kind of putting real names with them. So Golgi tendon's one. You have muscle spindle. If I said chemoreceptors, what do you think those detect? Chemical levels. If I said osmoreceptors, water levels. If I said thermoreceptors, temperature. If I said baroreceptors, see if y'all know this one. Blood pressure. Yeah, so they all do the same thing. They're detecting something, but now they just have specific names to them. Okay. So once they detect, they send input. We integrate, we send output, we cause a change. That pathway does not change. Okay. So stretch reflex, tendon reflex. Next one is called the flexor reflex, also known as withdrawal. Either name's fine. If you put your hand on a hot stove, what are you going to do with that hand? Move it. So everyone, here's my hand on the hot stove. I'm moving it away. What motion? I'm closing an angle. What motion is that?
That's flexion.
That's flexion. But I'm also withdrawing it. That's why the names can be either. Whichever name you like is fine. Withdrawal or flexor. Both are the exact same thing. Okay. So let's look at this picture. We're going in. Oops, here it is. We're going in with the sensory neuron. We're coming out with the motor neuron. Same sides or opposite sides? So what is this? Ipsilateral.
And it's always going to be ipsilateral.
Flexor working. But flexor usually doesn't work alone. It always has a buddy. So it works with another reflex. It can work alone, but it usually doesn't. Now look on the integration part, the gray matter. It doesn't matter which level you look at. Do you see one synapse or 2? So is it poly or mono? Poly. So flexor reflexes are always ipsilateral and they're always polysynaptic. Now this is the first time that we've seen multiple levels of the spinal cord. This is telling us that when you have an incident where you need to actually pull a limb away from safety, it's going to actually communicate on multiple levels of your spinal cord. So if I need to move my arm away, it's going to alert multiple levels of my spinal cord because it has to send signals down multiple neurons to actually move my arm away. Okay, this is called intersegmental. So all that means is we're going between segments of the spinal cord. Intersegmental is when multiple levels of your spinal cord are involved. So you don't need to write this down, it just kind of gives you an idea. This right here, the stretch reflex, this is happening around L4 in your spinal cord, so lumbar 4. That one segment controls this reflex. But because we're having to control muscles up and down your leg here, this is going to be basically L1 through L4 controlling this reflex. If it's your arm, it would be more like C5 through T4. It just depends on the part of the body you're looking at. Okay, so intersegmental just means multiple segments have to work together to cause a movement. Okay, so here you step on a tack. Does that feel good?
No.
So a sensory receptor detects that. They're called pain receptors. Nociceptors are their names. So a pain receptor detects that. How do we get that information into the spinal cord? Okay. So sensory receptor detects that. We send the information down to sensory neuron. It goes in the back of the spinal cord. That will never change. We're going to integrate it. Now when we integrate it, it doesn't just stay at that one segment. That integration information goes up and down the spinal cord as we're alerting multiple segments. Now when the integration occurs, how do we get information out? Okay, so we have integration, and then we have our motor neurons. Notice that all of the motor neurons have pluses by them, so what are we doing to them? It's exciting them, and we're telling your hamstring to do what? Contract. If your hamstring contracts, that creates flexion, so what am I doing with my foot now? Picking it off the tack. Okay. Flexor, when I do this, I'm closing my ankle, so I'm flexing. So this is basically just pull your body away from danger. Now, do you think about all these steps when it occurs? No, it happens pretty quickly and automatically, but this information is all going to your brain. So by the time you're moving your foot off of it, your brain's recognized that you are in pain. So you have that little delay to your brain. Okay, our last reflex is going to be called the cross-extensor reflex. This one always occurs with your flexor reflex. This one always has to have a buddy. Okay, so let's look at this picture. Goes in one side. So here's the sensor going in one side. Do we see stuff exiting both sides? So is it ipsi or contra? So the cross extensor is contralateral. Look at the integration. Do we have one synapse or lots of synapses? So is it mono or poly? So cross extensor is contra and poly.
Which one does it work with?
It works with the flexor. And it'll make sense when I show y'all. Okay. This is occurring at multiple levels of the spinal cord, so it's intersegmental. Notice that we're doing opposite muscles, so what would we call that? It's antagonistic, and what's the term for antagonistic? Reciprocal innervation. Yeah, it is. That's antagonistic works too, but Orion won't give you that credit. Okay, so notice this is where it kind of gets hard with this picture. Okay, this leg is withdrawing. This leg is extending. Cross-extensor reflex is a balance-maintaining reflex. It occurs when you are walking. So this reflex is really always in effect. You just never think about it. It's how you maintain balance. If I am walking, notice that the tack's back in the picture. If I'm in the middle of a step, like this, right foot went on the tack, I'm like this. Is my right foot going to notice that I'm on the tack? Yes. So, sensory receptor detects that. How does that information get to my spinal cord? Okay, in my spinal cord, what happens? And now what do we need to do? Send the motor. Okay. Well, I need to pull this foot off the tack, but what do I need to do with my other foot?
Put it down.
Okay. If I'm stretching this one out, what motion is that? Extension, and now what am I doing with this one? Flexion. Cross extensor, because it's crossing my body and extending a limb, works with your flexor, always. So it's a balance maintaining reflex, they have to occur together. Flexor can occur on its own, cross extensor has to occur with the flexor. It's balance maintaining. Yes?
Okay, is this the only one contractile?
That we're learning, yes. Contralateral, that we are learning, yes.
Okay.
Yeah, there's much more in your body that are, but these are the only 4 that we're reviewing.
Okay.
Okay. So, if we go here, pain receptors, nociceptors detect the tack. How do we get information up? Sensory neuron. Sensory neuron goes in, and what does it do? Integration center, which is basically lots of different levels. Then what happens? Motor neurons are going to exit on both sides. So since it's exiting both sides, is it ipsi or contra? Okay, and then it's going to go, the motor neurons go to your effectors. That pathway hasn't changed in any of the reflexes. What's changing is the events. Are we contracting? Are we relaxing? Are we stretching? Are we pulling away from danger? So that's really just the outcome is the difference. Okay, so that's all we're covering in chapter 13. Reflexes and basic pathways. So that means on Wednesday we're going to start 15. So just to give you a kind of a mind around what's going on, Wednesday, Friday, and the following Monday is 15. Thanksgiving break occurs. We have 1 class left after Thanksgiving break that Monday. We're going to do a review, full review of the entire semester in a game. It's going to be a game. You're going to work in teams. We may or may not use clickers. Depends. Okay?
Is 13, 14, and 17 on Spinal?
No, very, very little of it. 13 will be because I lectured over it. Okay. But 14, 15, and 17, I have a final review for you. It tells you exactly what you need to know. It's mostly terminology. Okay.
When did the open?
It opened last night.
Oh, it did?
Yeah.
Okay.
Or yesterday morning.
Okay.